Hey Hawks. Today we're going to talk about internal energy. And really honestly, we're going to talk about the energy inside a substance, looking at things like low temperatures, high temperatures. We're looking at heat, really. Okay. So the energy of one atom is very small, but there are enormous number of atoms in a substance. So all of the atoms undergo random motion. So let's say this is your substance, okay? And it's a simple substance that has two atoms that are bonded together. Okay. The bonds between the atoms jiggle and stretch. Okay. So if you think of the bonds as being kind of a coil type thing, they can bounce back and forth, and then the whole thing can spin, or the whole thing can move, that kind of thing. The molecules move around in the substance, right? So they can move around depending upon the state of the substance. Okay. The combined microscopic kinetic and potential energy of the atom is called the thermal energy. Okay. Heat energy. Thermal energy is related to temperature. Raising the temperature of substance increases the movement of the atoms, right? So, if we raise the temperature under a solid, eventually it becomes a liquid, right? And so all that's happening is that the atoms are moving faster and faster and faster till it gets to the point where it's like, oh, okay, I have enough room now, I can be a liquid. Okay. And then, if you think of a gas as a little kid on, with all the sugar and stuff and they're bouncing off the walls, that's pretty much what a gas is. As substances are heated, collisions with each other and with the wall of the container contribute to the increase in total energy. Okay. The potential energy increases due to the increase in space between the particles. So it's the space between the particles that defines the potential energy. The random kinetic energy increases due to the particles moving faster. So the movement of the particles, right, is what uh, affects the kinetic energy. Okay. The total of the potential energy and the random kinetic energy of all of the particles in the substance is the internal energy of the substance. The potential energy, which is the space between particles in a substance, contributes to the state, right, or solid, liquid, gas of the substance. Okay. Particles in a solid tend to be close together and they move very slowly. Sometimes they're just vibrating. Therefore, it has a high potential energy. Okay. The kinetic energy results from the speed of the particles within the substance. So, particles in a gas are far apart and moving quite fast. Thus, the kinetic energy would be approximately equal to the internal energy. Okay. So they're spaced out, they're moving around, right? The potential energy at that point is very close to zero. So at that point, then your kinetic energy would be equal to your internal energy. Okay. The relationship between internal energy and kinetic energy is that the kinetic energy is equal to 3/2 times, this is a constant, and then times the temperature. So kinetic energy is the kinetic energy, right, in joules. T is the temperature, but it's in Kelvin. Okay. And then KB is a constant, and it was found by Boltzmann. And it's 1.38 times 10 to the negative 23 joules per Kelvin. Okay. So if we look at the example over here, it says if a 100-degree 100 degrees Celsius particle with a mass of 4 times 10 to the negative 26 kilograms, calculate the velocity of that particle. Okay, so we know that we have our temperature, our mass, and we know the Boltzmann's constant. So we can get the kinetic energy, right, by doing 3/2 times that constant times the temperature in Kelvin, which we'll go over in the next video. And then remember, kinetic energy is 1/2 the mass times the velocity squared. So then you just take the thermal energy, right, the internal energy, and set it equal to 1/2 mv squared, which is the kinetic energy, and then you can solve for velocity.